Hi, welcome to Intermolecular Forces, Solids, and Liquids. My name is Dr. English. Today we're going to be talking about the characteristics of solids. Specifically, we're going to look at the kinetic molecular theory, types of solids, how solids form, melting point, freezing point, and sublimation. Kinetic molecular theory. According to the kinetic molecular theory, the state of a substance at room temperature depends on the strength of the attraction between the particles. So solids tend to have strong forces of attraction, liquids, moderate forces of attraction, and gases, weak forces of attraction. What is a solid? Matter in the solid phase has a definite shape and volume. Crystalline solids, which are known as true solids, have particles arranged in a regular, repeated geometric pattern. For example, the crystal lattice structure of sodium chloride is an ionic solid, and we can see repeating patterns of chloride ions and sodium ions and chloride ions and more sodium ions repeating in a regular pattern. Amorphous solids do not have a crystalline structure and are not considered true solids. Examples of these are glass, rubber, certain plastics, and maybe at some point in your life you played with this thing called oobleck. Oobleck is definitely an amorphous solid. Formation of a solid. A solid forms when the temperature, the average kinetic energy of the particles of a substance, is low enough that the particles are held in a fixed position. The particles in a solid vibrate slightly, but do not move significantly from their relatively fixed positions. We can see that in this animation here over to the right. As ice is added and the temperature goes down, we can see the formation of a solid. Now, these water molecules are in a fixed position, but as you saw, they were moving slightly. The particles that make up a solid are all moving slightly, moving a little bit, but there's not enough energy to overcome those forces of attraction holding it together, which is why it looks like a solid. Melting point. The temperature below which forces between particles, intermolecular forces, can hold the particles in a relatively fixed position. If heat is added to a solid at its melting point temperature, which is an endothermic reaction, the solid will change into a liquid. Freezing point. If heat is removed from a liquid at the melting point temperature, which would be an exothermic process, the liquid will change into a solid, which we know as freezing or solidification. Variations in melting point. Melting point temperatures of solids vary greatly in accordance with variations in the attractive forces between the particles. Thus, the melting point temperatures of a solid indicate the strength of the attractive forces within the solid. So we can see, based on a substance, the bonding that's involved, the melting point, substances with dispersion forces holding those molecules together will have the lowest melting points, where ionic solids typically, but not always, tend to have the highest melting points. So the general trend here is the higher the melting temperature, the stronger the attractive forces between the particles. Solidification, also known as crystallization and freezing, where a liquid changes to a solid. The opposite change, solid to a liquid, is called melting, or, as we've seen before, fusion. Both of these changes occur at the same temperature. It is possible for a substance to pass directly from the solid phase to the gaseous phase, or from the gas phase to the solid phase, without passing through an observable liquid phase. Solid carbon dioxide, otherwise known as dry ice, and elemental iodine are two substances that can sublime, in other words, going from a solid to a gas, at STP, which we know that means standard temperature and pressure. So carbon dioxide as a solid, otherwise known as dry ice, will go directly to a gas, and elemental iodine as a solid will go to the gaseous phase and skip over the liquid phase. So what did you learn? We talked about the kinetic molecular theory, we talked about different types of solids, how solids formed, We defined melting point and freezing point on a very general level. And then finally, we talked about sublimation at the end. Need more help? Feel free to contact me. Have a great day.